Welcome to Bite-Size Data Science. In today's video, Robert Uleman concludes his two-part videos with a discussion on subsetting. When you are dealing with multiple files or tables, subsetting is not as straightforward. Let's Robert explain.
Hi everyone, I'm Robert Uleman, Data Science Engineer for IBM Data and AI. I work on short-term data science projects helping customers on the road toward becoming AI-driven businesses. In a previous video, I covered how we needed to deal with customer churn data that came in as multiple tables, each spread over multiple files, and that was just too big and that was at the wrong level of detail. In that video, I covered at a high level how we merged, aggregated, subsetted, and transformed that volume of data. Today, I want to talk about one aspect of this, which is to use only a small part of the dataset so you can actually work with it. This comes up a lot. So much of our work is iterative and experimental, and you need an amount of data that you can comfortably work with and get fast turnaround on your experiments. If it takes half an hour just to read one file, and you've got 10 or 20 or 30 of those files, you're never going to make any progress because it takes a whole day just to get through one iteration. This video is about one technique, which is to extract a subset of the data by random sampling. It's a simple idea, and convenient library functions for sampling are available, but when it comes to applying it to big multi-file and multi-table data sets for a churn use case, there are some additional things that you have to deal with. Let's take a look. The key point is that you can't just load the whole dataset into a data frame and apply your favorite sampling method to it. Instead, you need a two-step process. First, create the subset of unique IDs that you're going to work with. Then you apply that subset selection to all tables, incrementally as you read in the separate files. And as I showed in the previous video, relying on a key feature of Spark, you do that at the same time as you're transforming, aggregating, and merging the total volume. You combine data from multiple tables into a single dataset by merging all rows from all tables into a single row for each unique identifier, or UID for short. Every table has a column containing this UID, otherwise this doesn't work. And one of the tables, maybe it's called users or customers, has a label column marking the UID as churn or not churn. Otherwise, you can't build a supervised classifier. That's the table we're going to work with to define the subsets for us. So what we're going to do is we're going to extract a new data set, the subset table, that consists only of those two columns, the UID and the label. Given some target subset size, we randomly select rows and add them to the subset. And then we use that to select just those rows associated with the same UIDs from the original tables. Now, it's obvious that we need the UID column to define the subset, but why does the subset table also have a label column? I'll explain that in a minute. The mechanism for applying this selection is a table join. For each ID in the subset table, you bring in the column values from rows in the other tables that share the same UID. With each table, the dataset gets additional columns, which are then filled in with the data for only the selected rows. Now, what's nice about this is that while you do this, you can choose to vary the percentage of rows that you select, depending on the label that they come with. Let me explain. In many use cases, and certainly for churn cases, there's a severe class imbalance, and that can cause trouble in training a classification model. Here, there are two classes, churn and not churn. Hopefully, in most businesses, the number of churners is relatively small. Let's say every month, 1% of your customers churn away and go to the other guy. In 10 months, that adds up to some 10%, but that's still an imbalance. To see why this is a problem, imagine a trading data set with 1% of records in class A and 99% in class B. A model always predicting B is automatically right 99% of the time, which sounds great, but is obviously not useful. It's hard for a model to home in on the minority class when the minority is so small. Now, when you're sampling the table to create the subset, you can select a higher percentage of the minority class and a lower percentage of the majority class, such that your sample has the total size that you want and the class balance has been improved. Of course, you want to verify that your choices really had the desired effect, and this is why we add the label column to the subset table. Another aspect to the subsetting process that your basic library function doesn't cover is that, again, in the churn case, you're looking for a pattern over time. Assuming that you have monthly data for customers over a limited overall period of, say, 10 months, there will be some customers that churned out right in the first month, and others that only appear in the last month. So those will only give you 1 month's worth of information, and that's not enough to establish a pattern. In your subset selection, you need to first apply a filter that eliminates any UIDs that don't have at least some minimum number of months of history. Finally, when you do this kind of sampling, you always have to be a little bit careful and understand your data well enough to be sure that you're not introducing a bias here. This is where randomization seed comes in. In software, a random sequence is really pseudo-random in that if you start from the same seed, you get exactly the same sequence. For creating a subset, this means that you can make your experiments, for example, as you try different target class balances, exactly repeatable, just by sticking with the same seed each time. Even better, by varying the seed, you can create different subsets. That lets you test whether the subset is large enough to be representative. If your model's results and performance depend a lot on which subset you use, you probably need a larger one. And that's it for creating subsets of large and complex data sets. I'm making the code available so you too can apply this enhanced subsetting approach to your next project. I hope you find it useful.
Please look at the description of this video to find a link to Robert's code. This way you can take advantage of these proven tricks and techniques. See you next time on Bite-Sized Data Science, and don't forget to subscribe.